interest of time, we'll simply start because there's lots of stuff to cover in this deck. Really trying to describe OpenDaylight from a slightly different angle and perspective for you. We'll cover few of the different things OpenDaylight is useful for in the bigger context of the whole kind of OpenStack reference. Many times in this conference, we are looking how we're doing as a community, what a specific project is doing, what do I have in this release or in that release. What I'm trying to cover here is something that is a little bit different, trying to kind of frame the boundary of what OpenDaylight is doing in the bigger context of the whole stack, and we'll use some of the favorite use cases that have been pointed out by other folks here this week in order to do that. So just for an appetizer here or to wake you up after lunch or whatever, we'll talk about service chaining as an example, but really the bigger context is how applications are interacting with the infrastructure. Then we'll zoom into the different roles OpenDaylight can play, which is the key theme of this talk, and look at, now that we put some ideas behind how all of the different pieces of the stack are there for us, when we put it all together, what do we really have today, what we still need to do in order to get more. And the last subject is going to be specific to infrastructure awareness at higher layers and the benefit it provides, and then wrap it up with call to actions. So this is just to provide some example of how things are potentially being used here. This diagram is taken from one of the ETSI reference architectures. You see the different VNFs being connected up there, and the whole idea is I need some network activity, some network boxes that are going to sit between the two endpoints. We want to carry with us some insight to the fact that service chaining is not really limited to telco or to cloud or to enterprise. Lots of the things we are doing here in this community are actually equivalently relevant to different market segments, even though the deployment and the adoption of that may vary on time. But when you look at telco, for instance, I think the reasons people are interested in service chaining are kind of almost evident. You have different users, they have different contracts. You may want to do stuff per flow, for example. Telco has different types of network. They deploy stuff in different kind of topologies, which by itself may create a need to do service chain, either restricted to a topology, cross topologies, and so on and so forth. In cloud, where all of this was born, it comes pretty naturally that you would like to have some firewalls, load balancer, WAN optimizers, whatever. And even you may want to think, even though some of your favorite cloud management systems do not support it today, that you want to bring your own. So I really like that firewall with that configuration. I really want that load balancer that is optimized for my application. I would be very happy to deploy it. Can I do that not as a VM, but as actually a privileged function in the network that the rest of the infrastructure would really be able to identify, and as such, provided some privileges to the network. And we'll touch on that. What does that mean to get privileged access to some of the network stuff? And in enterprise, similar use cases. And why are people looking into that? For reasons that have been already discussed, so I'm not going to get into this right now. But I want to take a step back first and look at kind of, if you want, something that we refer to as software-defined infrastructure that you are starting to hear more about in the industry, I think, right now. I just actually, a couple of days ago, saw somebody is already organizing an SDI conference later this fall. And the idea is not just to look at network, but to look at network, compute, and storage in some sort of holistic fashion. Everything is driven by cloudification, which really means automation, which really means the agility, the ability to move workloads at the speed of a mouse click based on a momentary needs. And when I start looking at things that way and looking at the application and then the different layers of, there's no pointer here, I think. Maybe there is. No, that was the wrong thing to push. There is recovery. OK. Not too much damage. Don't push buttons that you don't know what they're going to do, is the lesson. So anyhow, there are layers in the infrastructure. We are going to visit those. Orchestration, the control is, thank you. Oh, is that the same? It's going to work with this?
Yeah, you just have to press it.
OK. OK. Thank you, Asaf. OK. So the layers, the different layers is actually going to be what we are going to talk about. And you see at the bottom that ideally, if I could organize all of my resources in a pool, and at one moment this box in my infrastructure is more network-centric, and another moment it's going to be more storage-centric, that would be very interesting. It's going to lead to my ability at the business level to drive agility, to drive lower cost, lower CapEx and OpEx, and so on. But we have some challenges before we get to this wonderful picture. What is the right way for those applications to interact with this tech and specifically with whatever your infrastructure happens to be? Just to paint two extremes, I could say, because I like scalability as much as I can get it, I'd like to place it anywhere. I don't have one homogeneous infrastructure. So what I'd love to do is create those applications completely agnostic of the infrastructure. What do you think that's going to do? Is that a viable option? Nobody is, OK. We could make this interactive, guys, if you want to. So what's going to happen in that case is that you're going to also lose some optimization. Optimization is not here for the sake of performance only. Optimization here is for the sake of the bottom line, because if I do not have my infrastructure running as efficient as I can, it means that the cost per unit of compute, I'm using that in a most generic sense, is going to be high, so I'm not going to be able to compete in the market. So another way of saying that is that what we have seen in the industry originally was, oh, I can do virtualization, wonderful. I wasn't able to do it yesterday. But we are going into this era where it's not about just my ability to do service chaining or NFV. We are going into this era where it's also about my ability to compete successfully in that market. For that, I need to also be efficient. So when I create my applications in a way that is completely agnostic of the infrastructure, I'm also going to put or leave some performance on the floor, and I'm going to regret it later, and I'll show you some results by a third party in this talk as well. If I dial it all the way to the other extreme, and I say, oh, I'm going to make my application extremely specific to the infrastructure I'm using, obviously what's going to happen, it's not portable, I'm changing the infrastructure tomorrow, I cannot scale easily. So we need to find some happy in between. And that happy in between is this line that we are referring to as policy, some language that as an industry we need to develop. And SFC, service chaining, is one example of a use case we all care about that is trying to do that. In order to achieve that, there are two arrows over here. And we are going to spend 5 minutes talking about them in the next few slides. For that communication, now that I'm sure everybody is convinced now applications do need to have some dialogue with the infrastructure. So for that communication to happen, we need something that comes up from the infrastructure and tells the orchestrator and the control layer, our ODL in this case, what I'm capable of doing and what's available right now. And something needs to come from the top down and tell me what is this piece of compute trying to do. And we'll change pace a little bit and run a little bit faster as you see the basic concepts here. So the model is very simple. The implementation is going to be a little bit more complicated. I actually am trying to do in each of those layers a comparison between what is the service model, which have two inputs to it, my specific workloads and somebody who runs that infrastructure have their input, and what do I have in the infrastructure. I'm trying to compare them, and I'm trying to use what I know latest about that infrastructure. Very simple. When we start putting the details behind it, it's not going to be that simple. There is another principle that we want to use as I was describing the two extremes of completely agnostic, fully linked or specific to an infrastructure, which I'm trying to exemplify here with these two triangles. The policy obviously comes from the top and becomes very narrow and specific as we reach the bottom. So a specific piece of infrastructure really needs to know only what it needs to know. Otherwise, it's not going to scale. The details of the infrastructure, and we'll talk about the enhanced platform awareness work that we are doing, that obviously is rich in detail at the bottom and becomes a little bit more specific at the top, as I don't really want to, just a second, I don't really want to overload my orchestration or other decision-making mechanisms with too many details. I want to be extremely picky and take those relevant details and only those. Question?
Give an example what you mean with policy.
Yes, we are getting there. So if we want to talk about the ideal state, before we get into a specific example of a policy, there are many things that we may need to change in an existing reference that for this, the case of this talk, I'm referring to OpenStack, OpenDaylight, and OpenVSwitch. We may want to develop as an industry a policy API layer. For those of you who are more conversant in OpenStack, there are multiple projects over there. The scheduler we have right now in OpenStack is really compute-centric, is really not aware of network capabilities or constraints and storage as well. In the image, I may want to have some hints as to what that workload really needs, so I know where to place it. A specific example would be just generic compute versus some load balancer. A load balancer may need something different than compute. Lots of work happening in Neutron, not making as much progress as we would like to see. Philosophies and specifically Notchi would be useful to provide feedback as to the status of my infrastructure. We'll talk more about what I have in OpenDaylight, what we are doing as a community there. And OpenDaylight role here is really to sit in between the orchestrator and the lower level where the enforcement is supposed to take place and do some interpretation, do some instantiation, and expense that so that we know what action to take in the infrastructure. Okay, so am I done when I'm just talking OpenStack, OpenDaylight, and OvS? Not really. I'm not going to, in this talk, not going to go in that direction. But if we are talking about NFV, we need to take into account really the whole stack, as you could see on the lower right side, and really try to employ the same principles over there of these two triangles, these two arrows, I may need, even at the higher layers, to expose some of the capabilities so I end up deploying the VNFs in the right place. So I end up providing scalability, whether within the VNF or intra-VNF or having some geo requirements or whatever you have, you may want to have some awareness of the infrastructure there too. So the progress we have made is that whether you have telco use case on the left or cloud on the right, we are, as an industry, working on open source, converging around OpenStack and OpenDaylight, working in tandem together with a popular vSwitch in order to deliver those mechanisms. And so now we could start zooming in into what OpenDaylight is doing. I'm just quoting a slide from yesterday's keynote, and that gives me the justification to use NFV service chaining as a good example here, because this is really the way people are using today OpenDaylight. So if we really are trying to put the whole stack together for these three use cases, and I'm just highlighting the key actors. This illegible piece of the puzzle here is the work we are all doing together. It's the latest model for lithium OpenDaylight. We would need the following things if we are really trying to deploy that. We would need some policy that is going to tell me what is my application going to do. An NFV may be composed of multiple virtual machines. What's the connectivity requirement? What's the compute requirements? They need to be together. They need to be on different HA, different zones for HA reasons. This piece is going to scale. This piece doesn't need any scalability. Go instantiate another complete copy of this. When you run out of resources, when this piece fails, do so, and so on and so forth. There needs to be, and hopefully, Asaf, that answers some of your question. We need to have a way to communicate that in a standard fashion, and then it needs to work down all the stacks. We are creating overlays. How do we piece that together? How service chaining is working, and all the other pieces. So let's talk about what ODL is supposed to do in this rather complicated set of requirements and mechanisms. And I'm simply highlighting few of those. Note the legend. Some of these we could kind of claim as a community that we already have. Some of that we probably need to work on. It's not that those that we kind of have are done. There's work required there too, but you could definitely play with it, enhance it, and so on. So we expect out of an SDN controller to have some topology, sense of topology for underlay and overlay in the case of OpenDaylight, and some of the stats that are going to tell me up, down level of utilization. We expect an SDN controller to play the role of connecting a VM, and I'm just using one way of packaging applications. We are all aware of other ways, but right now let's keep it simple. How a VM is really connected to a network, and that could be maybe an overlay, again, just to keep it simple. We would like to create some service chaining, maybe in that policy also say something about can talk to this guy, cannot talk to that guy. We may want to consider the concept of a group, because what is a VNF? It's a bunch of VMs. Different people have different views of what that group needs to be and what is the relationship between its different members and how different groups are related to each other. But inside OpenDaylight today, we do have group-based policy. We do have SFC. And the good news is that out of Lithium, they actually are even communicating to each other, which allows me to do some meaningful things with them. I'm also claiming, based on the long preamble to this talk, that I want to do from the infrastructure, I want to have two mechanisms. I want to have a capable and available. I want to know that for this piece of compute, this infrastructure would be a good match. For another piece of compute, maybe another piece of my infrastructure. But I also need to know what is available, not only for compute, but also for network. If I'm trying to place a firewall that I expect to get 5 gig of performance out of, and I'm connecting that on a 1 gig NIC, it's not going to work that well. If I'm going to work with a vSwitch that at this point is overloaded or is architected such that its performance is capped, and well, compute is available on this platform, no problem. Memory is available on this platform, no problem. But the vSwitch is going to slow me down. And we also need to acknowledge the additional complexity. When you start the game, everything is available. Your initial placement for the first virtual machine on a platform, well, we could say it's not the most critical decision you're going to make, even though I'm going to claim, be careful with this one too. But when you start adding more virtual machines to that piece of infrastructure, now we are subject to all sorts of interesting, potential, damaging interference in a way that your performance is not what you thought you're going to get. And for that, we need to have some isolation. For that, we need to have some enforcement that happens on the platform. And actually, I would also love it if my infrastructure would be able to say, as the orchestrator above me that says, oh, I thought that should work just fine, is not aware of this, I may want to give him a hint, hey, you know, that's maybe not the best decision you made today. So we need to do some work, and I'll show you some early results. Security has come up multiple times. I'm not going to talk about it right now. And the concept of network-assisted VM placement is what I'm talking about when I'm saying be aware of the vSwitch performance, be aware of your network infrastructure performance, be aware of your network in general. You may put your appliance here and your VM there, and you'll be surprised that they are having some difficulty to communicate. OK. So with that in mind, I also want to bring to your attention some work that the ODL community was doing since the last release. And this has to do with the concept of S3P. I think that at this point, it is fair to say, and please challenge any statement like that if you like, that we are, as a community, making good progress on those promises. The first thing that we needed to do was to stabilize that. So this is not just an open source project, and God knows what happens when you're really trying to use that. It is really stable. It's going to work. However, because we have more than 40 projects, it is challenging to make sure that everything works. So we need to make sure that we have use cases that we have selected, and those have been tested properly. And the work that we are doing from the board, from the TSC, from everybody that is really doing the work and committing code is to make sure that we are addressing all of those efforts. And we also chose 2 use cases for Lithium: network virtualization and service chaining, which, again, in the surveys that the marketing folks are doing, you see that these are the popular ways people are using the platform. And I'll challenge you towards the end of this talk to provide some other examples of use cases that you think this community needs to actually go and deal with. So let's talk about the first role, kind of what would seem as very benign and simple, of course. Let's connect a virtual machine to the network. I'm using an old slide from the way Neutron looks at it. You may want to draw your attention to the two dashed boxes here, the kind of purplish and the red at the bottom. The distinction there is really who owns that piece. The one at the top is really owned by Nova. What we are using in our case is libvirt KVM as an example. Again, everything is as an example because we're doing reference architecture. We are not shipping this for a product from Intel point of view. And it connects the virtual machine through Linux bridges to the pretty elaborate two bridges that we used to have in OpenVSwitch. And so the way the connectivity works is kind of in two phases. You're placing a virtual machine. Obviously, you need to boot, and I'm not going to go into this whole lengthy process, and how did I get the vSwitch there, and how did I get the right vSwitches. There's lots of complexity. I'm trying to simplify that because I want to compare and contrast the way it works with OpenDaylight to the way it works without OpenDaylight. So this is with no OpenDaylight. I'm simply going from Nova is configuring those VMs and connects them. And the OvS plugin in Neutron is really about configuring the vSwitch in the right way, connecting it to the right network that is recognized by Neutron, and then making that connection here between the ways the VM are plugged in to the way the vSwitch is going to work. And there are multiple modes here. You could read it offline. I'm not going to have enough time to get into all the details. When we are moving in the direction of OpenDaylight, it becomes a little bit different. OpenDaylight is now the entity that controls the vSwitch. Not only in the OpenDaylight case, we have moved to a little bit simpler model for the vSwitch. There was a talk yesterday, and I'm going to refer to it in a second again, about the way DBDK is used to change and enhance the data plane of the server. And the change that happens here is that while we have Nova using the additional information about what the infrastructure is capable, so I chose an infrastructure that is going to give me the optimal results, it is now communicating to the north side of this bridge. ODL now steps into the picture. It needs to control that vSwitch instead of the work that used to be done by the OvS mechanism driver that was not anticipating the use of OpenDaylight underneath that. And I also could have other things that come to play, like policy. I have some different modes. The last one here is work that is happening in the OpenVSwitch that allows you to actually, if you had the right piece of hardware here, to move some of this processing, including policy, down to a piece of hardware. To put things in reference, when you use DBDK, this architecture changes a little bit, and the slides that you saw yesterday in the talk, if you attended that, and if not, you could probably fetch it online in a few days when it becomes available. We had another talk that was really covering the details of how DBDK works with OpenDaylight, the changes that are happening on the data plane, as well as the benefits from performance. And as we said, performance is not for fun. Performance is to allow us to compete. So DBDK has multiple modes. The one that was used yesterday was the one on the right side with shared memory, which has its roots in the way telco used to use it. In those cases, one entity controlled the box, so sharing memory was not a security or isolation issue for anyone. But as we anticipate people want to use that in more of a cloud style, where I want to have multiple tenants, where I do not have the trust in between them, we are also working on virt.io here as a way where There's no shared memory, so you are really adhering to the classical isolation constraints or requirement, and you are still not leaving too much performance on the floor. The other way to look at that, or the other project that I was talking about in OpenVSwitch, is you could think of this slide as kind of a summary of the different modes. One could work with a vSwitch. You could work with a vSwitch directly. Everything is in software. You have the choice, user mode, kernel mode, depending on the one you're choosing. You could enhance that using DBDK with or without a vSwitch. And the last mode here that I just want to bring to your attention is the mode that I actually, in conjunction with the OpenVSwitch, in a way that is A, coordinated, and B, seamless, so doesn't require you to do anything special, I could actually take a piece of the processing for switching, for policy, for enforcement that happens in the vSwitch, put it in a capable hardware, and now I gain actually even few cycles back, make my platform even more optimized and available to run the code that I really need. So these are just examples of what it takes to run a vSwitch and create a network virtualization with OpenDaylight, and some of the code contributions that we have done has amount to just enabling all of that to happen. But this is obviously just one case. Let's explore what happens when we are trying to do service chaining and specifically using NSH. So how many folks here are familiar with the NSH architecture? Can I skip this slide or spend a little bit? So we have Paul Quinn in the room, and he's the co-editor of the NSH. Your hand up. So if you have questions, you could ask him later. I'll just take a few seconds here to describe it for those who didn't raise their hand. So we start with some classification, and here are two very simple chains that I could go and employ to serve my needs. I could go between different service functions in a predetermined order. I could actually fork as well. I can have one service function that serves more than one service chain. The architecture is very, very flexible in that way. The elements of the architecture are right here. When you cross that imaginary domain, your classifier could be logical, could be part of the vSwitch. In OpenDaylight, the way we do it, it is actually running as part of the vSwitch. But what we have right now is a basic classifier. You could obviously bring your own and create a more sophisticated one. For instance, you could use DPI if you need it to be that way, but DPI could also be one of the service functions. You don't necessarily need to do it as the first step. But once you did it, we would like to go into SFC encapsulation, which in our case, ODL is going to be NSH. And this element of the architecture, the SFF, is the one that is the traffic or the highway patrol, if you want. And this is the entity that launches the traffic towards the relevant service functions. Those could be aware or unaware of NSH, and everything comes back to this guy. And this is the guy who's going to also allow us to scale. He is going to communicate with other SFF as the need may be. Few more comments here. I want to make sure we have enough time to cover everything and leave a few minutes for questions too. The way this magic happens is really by inserting two things here. This is your favorite VXLAN that had to be enhanced for a very simple reason. The original VXLAN didn't have a next protocol header, so you could not point to another header that we need here, which is the NSH. The NSH has a few things that it does. It has the notion of the spy, which is really whatever service chaining you chose for the day. It's also going to tell you where you are in that service chain and when you exhausted it, and maybe you had an error and you should drop at this point. And it also allows you to carry some metadata, and I provide here some example of how the metadata could be used to save you compute, to make you more agile, and so on. So a few more technical comments on this, and then we'll see how we play with this in OpenDaylight. Sure.
The NSH header, does it stay intact throughout the chain, or the DNS can modify the NSH?
So Kostas is asking, does the NSH header stay intact? The beauty of the architecture is that every service function could actually also be a classifier if you want. And because I have a firewall, then obviously I learned something about the traffic. So I may add my learning, or say I add DPI, I can add my learning into this and change the metadata. I could also, as service function number 3, make a decision based on some interaction with the control plane that, at this point, instead of going here to number n, I would go here to number 2. If I go to number 2 is part of a different chain. So I'm going to change the chain number if you want. So the short answer is absolutely, it has the flexibility for whatever you may want to do with it.
And you can have also nested NSH.
So that's an interesting topic that came up last week in the IETF. There are
Because in the following graph, it's been defined by edges that you can have nested graphs, right?
Right, and you'll find what happens recently in the IETF is that some of the Etsy guys, some of the telcos are becoming more interested in this and starting to work either in the IRTF, where they have NFV research group, or directly with the service function work group, and the need to map NFV forwarding graph to SFC is going to also behoove us to look into hierarchy in SFC. This is one of the drafts that the work group is considering right now.
And the third and last question is, do you maintain a database of those headers everywhere?
That's a control plane question. But the SFF actually, in its role as the highway patrol here, needs to know what service function I have on this node, and what service functions for this chain are going to be found where, so I could actually do my job. So I need to switch gears here a little bit. So 2 comments on this slide. You have a choice. Depending on the scalability, by the way, that you need, you could deploy this as the protocol itself is transport independent. So you could have service functions that sit on different types of transport, and yet they could be connected to a one useful chain based on your needs, which also means inter-data center if you so choose. You could implement that as 2 independent layers. You could actually merge it into a single overlay. And the example that we have with OpenDaylight is actually on the right side. One of the things that Intel is pushing in the standard, and we're working with other folks on those standards, is really the openness and the interoperability. And OpenDaylight plays a very interesting and important role here, because you actually have code, you actually have bits. You could actually go, contribute to this, play with it, understand how the different headers are working. And I think that's a really good and important service that we have for the community. A slide I'm borrowing with pride from the presentation Cisco provided just a couple of days ago in the IETF is trying to tell you something that is rather important, and this is now OpenDaylight specific, that the 2 types of policies that we had, one with group-based policy where you put some of your entities, VMs, in a group and some other in another group, and you define the contract between them, what they can and cannot do together. You could think now of SFC as another group like that. And actually, as I'll show you in the next slide, it's more than that. We made really good progress in lithium, such that, and credit is for everybody who worked on this project here, people from Cisco, from Ericsson, from Intel as well, so that I can actually invoke SFC from group-based policy. And hopefully that helps you with the question of what we are talking about policy. To me, this is just an example. It's just the start of a more elaborate interaction that we need to have between what applications need and how the infrastructure responds to that need. But that is a very popular use case, and so we have that already working in OpenDaylight right now. Just a comment here to relate this to the previous slides. The notions of VNFs versus VMs, so be aware of the fact that OpenStack obviously doesn't know anything about VNFs, and so that's why I'm saying, okay, it's really OpenStack and Meno, but this is a very simple diagram, just trying to tell you what happens here. That's a demo that we did, again, was referred to in another talk yesterday. So for interest of time, I'm not going to go into the details of that. So now I want to start putting things together. I want to leave you with some impression of, OK, what the hell do I get when I start putting things together? If I want to create this kind of a graph, I'm classifying stuff, I have this kind of policy, and I have those applications. At the OpenStack layer, because today it's not really a policy API, we do not have agreement in the industry how to do that. There are multiple projects, and new projects are popping up every OpenStack summit on how we do that. We do not have a way to simply go and say, this is the way I need to work. As we'll go to OpenDaylight, you will see that we have much more progress in OpenDaylight, and so OpenDaylight actually shines in that way. We also have issues in Neutron right now, where there is no service chaining available in Neutron. I'll show you the latest and greatest on this. In OpenDaylight, we have all of this figured out, and we have that also integrated with the OpenVSwitch. OK, so here is a little bit basic diagram just to try and stitch everything together. So I'm using a telco application. Again, it doesn't matter. There are two ways primarily I could do things right now. One way is to simply work directly with OpenDaylight. And I could go to the SFC. It exposes its REST API. And then I could go to my favorite infrastructure. And we worked on the automation of SFC towards the server, and how I would get the SFF configured, and how would I get the policy in there, and so on and so forth. And that kind of interface is going to stay there, as you'll see in the next slide. OPNV has latched on this, and this is the way they are going to use it for now, simply because the other one, the red one, is still going to have some challenges to it. Work that we are doing right now was not to get service chaining in Neutron, but rather allow Neutron to be aware of service chaining, so that when we get the VMs and they are placed down here, and I'm simply trying to make sure the network is doing the right job, and the network is aware that this is a service function, because I'm sure at this point everybody noticed from the NSH slides that service functions would love to have the NSH header because they need it in order to do their job, or they need to change the metadata. How does the vSwitch know that this is a service function? Well, somebody needs to tell it. So there is work for us to do. There is benefit from having these two layers, the orchestrator and the SDN controller, simply be in sync, so that when you're placing a virtual machine, Neutron Nova is aware that that is going to play a role of a service function. And I am going to avoid race conditions where a service function is not available and I'm already starting to spray traffic in that direction, all sorts of the little things that you really want to not get a phone call in the middle of the night. So that is the work that we are trying to do right now in Neutron in order to enable that. There are many other things that are needed, as you see. I'm pointing here at the bottom to that blue arrow over there that is supposed to create that linkage. I also want to highlight the green arrow over there, which was the new piece that happened in Lithium release that is allowing group-based policy to invoke SFC. So if you come from here and you're using Neutron APIs of OpenDaylight, you could actually work with group-based policy, and group-based policy is going to help you invoke SFC on your behalf. There are other projects. We don't have time. We're not going to go there. This is for your reference to show that OPNFV is really using those mechanisms that we are building over here. I want to switch to EPA, spend maybe 2 minutes on this, and then wrap it up and have 2 minutes for questions too. So we talked about the need for the infrastructure and the application to communicate a little bit. So you would say, oh, OK, this is somebody who works for a company that happens to provide some servers here and there. What do I really need something like that? And so I'm going to claim that for a bunch of reasons, you really need to do that. And I want to bring it really close to home. The way to do that is to compare two different, if you want, philosophies, mentalities, ways people deploy applications in the real world. If you go to Amazon as an example, you don't really know what is the underlying architecture for you. The workload is going to be deployed on something. Yes, it's going to do my work. The optimization is the challenge of the service provider in this case. And the kind of stack I'm going to have is most likely going to be something of that nature. And my traffic is going to have to go through all of those layers and have bottlenecks. The telco community is coming from an embedded environment where they have been used to having full control over their infrastructure to the point that when they need it, they get to bypass it. And that's, as an example, the way DBDK is serving their needs in order to cut latencies, to eliminate jitter, and improve the performance of the platform altogether. So, but there are other aspects of that that are important for me. When I start looking closer into a server, a modern server of today, I'll find that, it's multiple core. It has a dual socket in north of 80–90% of the cases. There is difference whether my NIC is really tied to this core or is really working on behalf of that core. And the memory that I'm using, is it really close or is it one hop away? And my performance is going to vary dramatically, and the utilization of my platform along with the cost of running that is going to vary dramatically. So what I want to do is be aware of that. I obviously don't want to do that as an application developer. I want to trust my orchestrator to do that for me. I want to trust my SDN controller to take care of the networking aspect of that. And the benefits of that are going to be, if I compare these two speedometers over here, the benefit is going to be something to the tune of this slide that you see here that was produced by a third party. If you are simply looking in a very artificial environment where this is the only variable we change between these two platforms, and there's nothing else running. As we talked about earlier, when you have more stuff running, it's even more complicated. This is the difference of what you get. It's a remarkable difference. So you need to be aware of that. We had public demos where this was shown. So to wrap it all up, given 57 seconds, ODL, as a community, I think we took the right step in the last release by promoting the ability of everybody to use that with the S3P. Really, I think for those of you who are involved with active contribution, it's really going to be beneficial if you get involved with this. We are doing that. We encourage you to do that too. We promoted 2 use cases in this release. What do we need to do next? I gave you some hints of where we think we need to go. Maybe you have better ones. Please let us know. And obviously, use OpenDaylight. Any questions? 3, 2, 1. Thank you very much. Oh, one question.
What do you think the biggest gaps are today? Do you think it's at the OvS level, the ODL, OP, NFV, OpenStack?
So it depends what you're trying to do. The gaps are going to show up in different places in the stack. Depends on what you're trying to do. I was able in this time frame, in order to paint a broad picture for you, I was just touching very lightly here and there. Pretty much anything that you didn't have tested top to bottom is not going to work. I gave you one example of, say, SFC. Well, you absolutely can use it today with OpenDaylight and OpenVSwitch. When I say absolutely can use it today, very careful with that statement too. It's working today. Does it scale? Does it have a full control plane that you are going to need in your application? Well, obviously you need to build on top of that, but that's what you expect from an open source project. Can I get it to work with OpenStack? As we go north, the unfortunate divergence is larger than it is as we stay closer to the platform. So I think that what you find is this triangle again, closer to the platform, ODL is the next layer next to the platform. I think as a community, we are doing a very reasonable job. Obviously, we could do much better. As you start getting higher and higher in the stack, more players, more different directions, so your mileage is going to vary. Any other questions? Okay, thanks everybody very much.